Let me begin with a word of prayer. So, Dear Heavenly Father, we thank you for this day. Again, I thank you for these students, and just ask that you'd bless our work today, help us to just finish what we need to cover, and just help the students have a good break, Lord. I pray, Lord Jesus. Amen. Okay, so were you guys successful in following my instructions? Anybody? Nobody? All right, well, let me just work through it then. So for equations 1 and 2, what I do is I multiply equation 1 by 2. That gives me 8x plus 6y plus 2z equals minus 34. Then I look at equation 2 right under it, okay? And then what I can do is I can subtract those equations, and in so doing, eliminate z. All right, so that's the first thing, first order of business. Eliminate z from equations 1 and 2. What's that? Oh, but subtract. So 8 minus 7x. Yeah, plus 9y equals minus 30. And let's call that equation 4. All right, so that's first thing I do. Second thing I would do for 2 and 3, so that right there, folks, is the first thing on my to-do list. And by the way, this advice I'm giving you here at the top of the board, this is a strategy for solving 3 equations and 3 unknowns by, this is a systematic method that'll work if the problem's harder, right? Like the first one we worked last time, the 3 equations and 3 unknowns, was super easy, right? We just added the 2 things, y's and z's both canceled, and then we're pretty much done, right? But if the problem's more complicated, you have to have a strategy. Yeah.
Wouldn't it be 34 instead of negative 34 since it's times 2?
What?
It's negative 17. Wouldn't it be 34 since it's times 2? I think it's times 2. Oh, never mind.
Oh, okay. It's all right. I made many errors in this problem yesterday, but that's because I made the mistake of trying to do it at 8:15 in the morning, which is just a bad idea. So then, if we do 3 times equation 2, and if we do 2 times equation 3, then that'll make the z terms match up. All right. So 3 times equation 2 gives me 3x minus 9y plus 6z equals 3 times minus 4, which is minus 12. 2 times equation 3 gives me 22x minus 4y plus 6z equals to minus 8. All right. Again, I've made them match up so I can subtract the equations. Now, if you don't like subtracting equations, of course, you could be more deliberate in your multiplication and make one of the multiples negative so that when you add it, they cancel, right? You can either add or subtract equations. It's really up to you. I just chose to subtract this time. The bigger point is you have to have a game plan for eliminating z. And the way to do that is to make the z part of both equations match up so you can either add them or subtract them. Anyway, so what we get here is minus 19x minus 5y, z's cancel, and equals to, looks like minus 4. So that's my equation 5. At this point, I have completed this part. All right? Now, if you look at equations 4 and 5, we're back to 2 equations and 2 unknowns, so we can solve those. Yep.
Equation 3 is 2 times negative 37. Wouldn't that be 60?
Oh, thank you. Yes, I copied the wrong number. So what is 2 times minus 37?
62, I think. Or that's, no, it's negative 74.
Negative 74. And you were telling me what the final product is down here, which was what?
I think that's
62. All right. Yeah, thank you. I prefer my corrections as soon as you notice them. There's a kind of student who waits 10 minutes to tell me that kind of thing. Evil. But okay, so then let's look at it. We've got this one, and I'll write 4 over here. We've got 7x plus 9y equals minus 30, right? That's my equation 4. So to make these match up, what I'm going to do is just multiply equation 5 by 9. And I'll multiply equation, let me just do that. 9 times 19 is 171, so minus 171x minus 45y. 9 times 62, which is, what, 558? And let's see here, then I do 5 times equation 4. That gives me 35x plus 45y equals minus 150. At which point I can add these equations, right? Because I've made the y terms match up. And when I do that, that gives me minus 136 x equals to 408. That gives us x is 408 over minus 136, which is minus 3. So apparently x is equal to minus 3. Then what can I do? I can go back to one of my equations 4 or 5, right? I can figure out y. So like from equation 4, I have 7 times minus 3 plus 9 times y, which I don't know yet, equals minus 30, which says that 9y is equal to minus 30 plus 21, which is equal to minus 9. So y is equal to minus 1. This is not my usual speed of calculation. I've worked this problem. This is my 4th time working this system, okay? So that's why I know all these numbers. I'm not actually doing the arithmetic. I'm just remembering it at the moment. But anyway, because I got it wrong yesterday, sadly. Okay, anyway. There's that. And then how do you find z? Right, I would, yeah, use, I think equation 1 is the one to go with, right? So from 1, we've got what? 4x plus 3y plus z equals minus 17, which particularly gives us minus 12 minus 3 plus z equals minus 17, which tells me that z is equal to minus 17 plus 15, which tells me that z is equal to minus 2. So in short, the solution, I'll write over here, what is the solution? The solution is minus 3, minus 1, minus 2. All right? Now, something I've shared with the other classes, so I should probably share with you guys too, is there's a way we can check our answers. And I think checking answers, okay, two equations, two unknowns. I don't think you need technology to check 2 equations, 2 unknowns. 2 equations, 2 unknowns you can do carefully on paper by yourself. You don't necessarily need to check that with technology. I think 3 equations and 3 unknowns, if you have the option to check your work, you know, it's not a bad idea, right? So one way you can do that is with this website, if I can get to it. All right, so let me take it back a step here. So the way to use a website to solve these kind of problems is, I think I wrote out for you guys the system of equations in variables before, right? Like last time. So basically what you do is you, well, let me not state the general thing here because we're a little bit short on time, but I'll just apply it for this problem, okay? So what you do is you take the system that you're given, right? And you just ignore the letters and you just write down the box of numbers that corresponds. So in this one, is everybody, can I erase this part here? Because I'd like to write there. So what you do is you write down what's called the augmented coefficient matrix. And the augmented coefficient matrix here is really, you have to put the equations in order. in so-called standard form. But once you do that, the augmented coefficient matrix, you just strip the numbers off. So like we get 4, 3, 1, minus 17. All right? And the next one you've got 1, minus 3, 2, minus 4. And the last one we've got 11, minus 2, 3, minus 37. All right? And then if you have like a, TI 84 or higher, there's a command in there that's called the reduced row echelon form, or the RREF. And no one calls it RREF except for me. I'm an idiot. But if you had, some of you had a high school algebra class where you looked at boxes of numbers and you did row operations on them. Do you remember that? Nobody? Yeah, okay. You do. You remember. So this website right here, which is available on my, if you look at my website, if you look down my Supermath page, down the links to websites that do the math for you, it's number 3 on that list. And so then you're looking for transforming a matrix to reduce row echelon form. Which is number 3 there too. And, oh, you got it, thanks. So I click on that, right? And then that takes me to a place where I decide how many rows, how many columns. So how many rows? We've got 3, right? How many columns? Well, we've got 4. So I click like that. It takes me to this other page. I put the numbers in, right? I've already done that though. So here it is. You put the numbers in, and so for the problem that we're just looking at, the numbers are, 4, 3, 1, minus 17, and so forth, right? Then what these steps are, these are so-called row operations. Those correspond to either adding equations or multiplying the equation by a number. Those don't change the solution set, right? So you can do row operations as a notation for the kind of elimination steps we've been making. And now if you want to see this in a course here, take linear algebra, right? We don't, that's not required material in here. Not at this point anyway. It was once upon a time. But anyway, so here's the RREF, the reduced row echelon form. It is 1, 0, 0, 0, 1, 0, 0, 0, 1. And what do we got? Minus 3, minus 1, 2. Minus 2, right? And what's the answer? See? So you can check your answer like this. You can also check your solutions with like Wolfram Alpha. If you just put the equations in as a list with commas separated, it'll solve it too. Which is easier, I suppose, for you guys than this website, maybe. I suppose while I've got this contraption open, I should probably do that annoying top hat thing. All right, so anyway, let me take a breath here. So that's it for systems of equations, all right? So what's left in your homework, there's a couple of applications of systems. It may not look like it at first glance, but that's the nature of the problem. So let me look at that example here with you guys. So like example 1 for today, I suppose. You've got y equals ax plus b through, and the equation, it passes through the following points: minus 5, minus 18, and 3, minus 2. All right? So the question here, this is number 25 in the homework, all right? The question is, can you find A and B, which makes the line go through the points? So how do you do it? What do you guys think? What should we do here? Everybody's got the top hat, right? Oh, I better leave it open though, because I want to use the computer again to cheat for a second. Okay, so we just plug the numbers in, right? So what that means is minus 18 is equal to a times minus 5, right, plus b. And the next one tells me that minus 2 is equal to a times 3 plus b. Okay? Do you guys see what I did? Do you understand that? Does that make sense? For this graph to have these points, that means I have to be able to put that in for x, and this, of course, is my y, right? But what is that then? We have what? We have minus 5a plus b equals to minus 18, and 3a plus b equals to minus 2. Now, I don't need technology to solve this system, right? We can solve this by hand. It's pretty easy. What do you do? Subtract. Yeah, very good. We subtract these equations. And so doing, what happens? Yeah, negative 8a equals to negative 16, right? So a equals to 2, which tells me b is equal to what? Minus 2 minus 3a, which is minus 2 minus 6, right? Minus 8. So y is equal to 2x minus 8 would be the answer here. Let me check my answer here. Yeah, that's the answer. See, so that one's not too bad, is it? Now, you guys might have solved that problem a really different way, right? You might have solved it like, oh, this is like y equals mx plus b, and use that kind of thinking. But, you know, now that we know about systems, we can view it in that regard. Now, this next problem is pretty similar, all right? But well, we're a little short on time, so I don't think I want to actually work out the system of equations which is going to result here. So what I'm going to do is I'm going to set it up, and then we're going to use technology to solve it, okay? So example 2, this time we've got a parabola, y equals ax squared plus bx plus c. And we're given that it goes through points through 2 minus 8. Let me say it this way, 2 minus 8, minus 4, minus 68, and also through minus 3, minus 38. All right? So each one of these points gives me an equation for the model, right? And what are those equations? For the first one, I get minus 8 is equal to a times 2 squared plus b times 2 plus c. The second one gives me minus 68 equals to a times minus 4 squared plus b times minus 4 plus c. The third one gives me minus 38 is a times minus 3 squared plus b times minus 3 plus c, right? And let's clean it up, right? Let's clean that system up. So what we really have is 4a plus 2b plus c equals minus 8, and 16a minus 4b. Did I copy something down wrong? Oh, okay.
I forgot you don't have to square on the a.
Oh, yeah, right. It's just the number.
You square the number, not the...
Exactly. Let's see here. So that's 9a minus 3b plus c equals to minus 38. Now, actually, we could solve these pretty easily. Maybe I should just do that. Yeah, let me just solve this. I'm going to put away the technology as much as it's... you know what? Let me show you the other technology. Yeah. Let me bide my time here. So if you want to solve a system like this in Wolfram to check your answer, what you can do is you can put them in as like a list. So what is my equation? What is it? 4a minus 2b plus c equal to what? I can't read it from here. You guys have to tell me. What's that? Did I get it right? Negative what?
8.
Negative 8. And then what's the next one? 16a plus 4b or minus 4b?
Minus 4b.
Plus c equal to what?
Negative 68.
And then what's the last one? 9.
9a.
Mm-hmm.
3b.
Minus 30 what?
8.
38. All right, so what I did was I put the equations in as a comma separated list like that. And so comma is and. So when Wolfram Alpha tries to solve this, it's trying to solve them simultaneously. Hopefully it will.
First equation is wrong.
First equation's wrong?
Should be 4a plus 2b.
Plus 2b. Try it again. Did I actually get those equations right? That looks uglier than I expect.
Oh, wait, it's supposed to be minus 3b, not plus 3b.
Yeah, that'll do it. That's the thing is all you got to do is mess up one sign, it all falls apart. These are very unforgiving in that regard. Aha! That feels right. So, as you can see, the solutions we should find are a equals minus 4, b equals 2, c equals 4, okay? Now, you don't have Wolfram Alpha on quiz 3 or test 3, right? So how would we solve this by hand? What do we do? I wanted to show you that's an easy way to check your work, right? That's my point there. My point is not to do them like that necessarily. So what I do is I'll label these equations 1, 2, and 3, right? And so what I'm going to do is I'm going to eliminate C from equations 2 and 3, right? Rather 1 and 2. So if I do equation 1 minus equation 2, that gives me what? Oh, you know what? Let me do equation 2 minus equation 1. Oh, whatever. I did 1 minus 2. So 1 minus 2 is what it is. We can deal with some minuses. So 4 minus 16 is minus 12a. 2 minus a minus 4 is plus 6b equals to 60, right? And if we look at, let's say, equation 2 minus equation 3, what's that give us? 16 minus 9 is 7, right? Minus 4 plus 3 is minus b. And that gives us a minus 30. All right? Now, when I see a system like this, I think substitution, right? So what I did was I deliberately eliminated C, right? That's what I did. Now I'm going to use substitution to finish the problem. Substitution, I can solve this one for B, right? B is equal to what? B is equal to 7a plus 30, is that right? Okay, and then what do? We take that, right? And we're going to plug that up in here. And that is going to give me minus 12a plus 6 times 7a plus 30 equals to 60. Now I have one equation and one unknown. So I use substitution to eliminate b, right? Substitution eliminated b. And then what I'm looking at here is minus 12a plus 42a plus 180 equals to 60. So that gives me 30a is 60 minus 180. What's 60 minus 180? Negative 120, which gives us a is equal to 100, minus 4, right? Because 120 minus 120 over 30 is minus 4. Then you take that and you plug it in back into, work your way back up here, right? So that's b is equal to 7 times minus 4 plus 30, also known as b equals to 2, because 30 minus 28 is 2. And then I you pick your poison, whatever one you want to find C, right? Which one would you use? I guess I'd use equation 1, you know? C is equal to minus 8 minus 4a minus 2b from 1, which gives me minus 8 minus 4 times minus 4 minus 2 times 2, which is, you know, minus 8 plus 16. Let's see here. Well, it's 16 minus 12. So 16 minus 12 is 4. C is 4. Which, of course, is what Wolfram Alpha told us, right? C equals 4, B equals 2, A equals minus 4. So it checks, right? But we need a method, right? Because, again, in the same way that, you know, a marathon runner can't use an electric bike, you know, you can't use Wolfram Alpha on my final. Sorry. It would be something different. If you could use Wolfram Alpha on the final, I would completely have to redesign the course. Like, it would be a totally different course. Anyway, so the point here is the answer is y equals 2. So the answer here is not the triple minus 4, 2, 4, right? The answer here, we have to go back, the meaning of it. A is what? The coefficient of x squared, right? So A is minus 4x squared. B was 2, so plus 2x. C, 4. So there you go. I think this is really neat because if you start thinking about this, this means that if you can solve systems of equations, right, you can fit polynomials, right? If we knew how to solve 4 equations in 4 unknowns, if we had 4 points, we could find a cubic that went through those 4 points, right? But we don't want to solve 4 equations in 4 unknowns here, do we? No, we do not. Uh-oh, somebody's calling me. Voicemail, missed call. Probably my extended warranty again. Let's see here. All right, so the last, now, okay, so we could even take Wolfram Alpha out for a spin on the last problem. Let's try for just a second here. So if you're lost and you need help on the last few problems, you can use Wolfram Alpha, but you do want to find a way to do them without it too, right? So here's the number 27 is x plus y equals 13, and x squared plus y squared equals 85. See, we have now just left the world of linear equations, right? So here's a picture. So this, I don't know if you, can you guys see the picture? So let me write down the problem that we're solving here at the moment. So this is problem 27 in your homework. It's x plus y equals 13. So here we're up against x plus y equals to 13 and x squared plus y squared excuse me, equals to 85. I wanted to warn you something. What example is this? Example 4, is it? That was 1. That was 2. This is 3. 3. So I noticed that there's some language about complex exponents in your homework. It's like, give all solutions of the nonlinear system of equation, including those with non-real complex exponents. I think that's an empty threat. I looked at all the problems I've assigned you. There's no non-real complex exponents, and it's really kind of weirding me out that they're talking about that in your college algebra homework here. If I could delete those words, I would. All right, I want you to solve these systems looking for real solutions. That's what we're interested in, okay? And so when we're solving a system, of linear equations, right? We started by talking about how if you have two equations, two unknowns, we're just looking basically for the intersection of lines if there is any, right? Oh, what am I doing? Sorry. And then, I didn't talk to you about this, but three equations and three unknowns is actually describing planes. So if you have an equation with three variables, that's actually describing a plane. So if you have like x plus y plus z, it's a plane with the normal vector, which goes in the 1, 1, 1 direction. So something like this, you know. And so if you have three equations, it represents three different planes. And if you think about three planes in 3 dimensions, they're going to intersect at one point if they're not like parallel planes, you know. But the three planes could be parallel, then there'd be no solutions. You could start thinking through this, all right? But anyway, if you want more of this, come to my linear algebra class. But this here, again, we can think of geometrically, see, because each equation corresponds to a graph, right? And so to find a solution to both of these at once is to look for intersection points to the graph. So we can kind of anticipate what we should be looking for, right? Because x squared plus y squared is a what? Equal 85. That's a circle of radius 85, right? And the top one, x plus y equals to 13, that's just a line with slope -1 and y-intercept 13, right? Because y equals to 13 minus x, right? And you can see it over here, right? We've got the circle, and that line happens to intersect the circle. But what would happen? Does it have to intersect the circle? Surely it doesn't, right? Now, this problem, this is number 27 in your homework, is really super duper easy. Let me show you why. Because in number 27, they tell you, all right, they tell you the nonlinear system has two solutions, one of which is and they give you this. They say it is 6, comma, fill in the blank. All right? So this is exceedingly silly as a format for a problem because they've just told you that your solution has what? It has x equals to 6. So what can you do with that information? You're right. So you can put 6 up in here, right? So exactly. You got 6 plus y equals to 13. So y equals to 13 minus 6, which is 7. So apparently the answer is 7. Yay. Now you're like, wait, but you didn't use the other one, did you? That's right, I didn't. Because you don't need to. The problem presupposes that in some sense. Here's what would happen though. This would give us 36, right? 6 squared is 36. Plus y squared equals to 85. Let's see where that leads us. Y squared is 85 minus 36, which is 49. So this tells us y is equal to what? Plus or minus 7, yeah? But the thing is, that minus 7 solution would have been extraneous. If we'd started with what I wrote, suppose that you started with what I wrote in blue, right? You might think there are two answers, but you'd have to throw out the minus 7 solution because of what I wrote in purple. Because what's in purple forces it to be 7.
Yeah, it would make sense.
Now this problem is very, very artificial because they tell you that 6 is the x value, right? This is very kind of, in a word, lame. How do you solve this problem without that? And let's try this out. I think you can see that if I increase the y-intercept to like, let's say 30 instead of 13, is that really just a 13? Where's the, oh, here's y. I'm a dummy. See that? Here's where the y-axis is. So 13's here. I think if I increase the y-intercept to like 20, this shouldn't have a solution, right? So example 2, let's try to solve something a little bit. Example 2, am I working back in time or something today? What's going on? Example 4, let's try something similar but different. X plus y equals to 20, all right? And x squared plus y squared, I'm going to make the number nicer. I don't want to use 85. 85 is ugly. Let's use 20. That's too easy. 40, all right? Does this have a solution? And how would you find out? One way, right? A completely legitimate way would be to graph it. And if you could graph it and see clearly that the circle doesn't intersect the line, no solution, right? But we can also take an algebraic approach. How do you solve this? What's the method you use for these?
Could you square, or not, like square both sides, or
Square both sides. You could do that. That's not crazy, but that's not what I was thinking. But yeah, let's try that. Why not?
Like technically would it be x squared plus y?
So just before I chase this rabbit, and I think it's a good rabbit to chase, you could just solve for y in the top equation and substitute into the next one. Then you just have an x equation. But I kind of like what you said, because if I square the first equation, that's not crazy. That's x squared plus 2xy plus y squared equals to 400. And then I could reasonably subtract that, and that would give me 2xy equals to 360.
And then you're so stuck.
And then that would give me, you know, y is equal to 180 over x, right? And then I can plug that up into the x plus y, like that. And then I can multiply that by x. Then I can rewrite that as that. Then I can complete the square. And that will give me that x is equal to, well, so x minus 10 squared equals to, looks like minus 80. So x is equal to 10 plus or minus I root 80. But nope, so there's no solution.
So that's way to work.
There's no real solution. Now, so your idea to square the equation, I like it. I mean, it's not wrong. We definitely could have. You see my idea that you just pick the easier equation, right? Solve for one of the variables, plug it into the other equation, see if you can face the music. Yeah. Let's try a different problem. Now that's so. So the ideas that we've already come up, used in two equations, two unknowns, they're useful to us here again. Do you see what we just did? I mean, we used the adding equations idea, right? It's not, but I had to do something kind of sneaky and creative that she suggested to get there, right? Like, if I was in a different section of college algebra, that would not have been suggested. I don't think. I mean, the last section today will ask me to do something crazy. There's no telling what they'll do. But 4x squared plus 5y squared. This one though, just kind of yells at you. Think about using x squared and y squared as variables. All right. Now, to properly understand these problems graphically, we need to talk about something called hyperbolas, and that's not something I planned for this semester. So we're going to have to take an algebraic approach here. All right. So what should I do? I want to get rid of the y squareds, right? So make the y squareds match up. So like if this is equation 1 and this is equation 2, we'll take 2 times equation 1 and we'll take 5 times equation 2. That'll give us 8x squared plus 10y squared equals to 82. And 10x squared, 5 times 5 is what? 25. 25x squared minus 10y squared equals to 5 times 43, 215, right? I think. And then we can add these dudes, right? And in so doing, y squared is no more. Oops, What's the name of the villain in the new Marvel movie? There's a lot of them. The one about the...
Can you describe him or her?
It's like some like underwater dude or something.
Oh, the villain in Aquaman? That's DC.
Oh, no, not... That's okay, never mind. All right, we have established that no one cares about Marvel movies. Very good. All right.
Marvel's.
Like you have no idea what I'm talking about. That's pretty great. So like no one's seen Wakanda Forever apparently. All right. 33x squared equals to what? That gives me hope for your generation. All right, so let's see here. 290, 297, yeah? Is that right? Did I add right? And then what?
You divide by 30.
Divide by 33. I sure hope that's nice. Well, I did copy this problem out of your homework. There is hope for it being nice.
It's 8, it's 27, 9, 90. That was not correct.
You guys are cracking me up. Oh, man. Well, the bad news is we're not going to have enough time to work a lot of these today. I hope I've started to share with you the principle by which they're solved. It's 9.
That makes a lot more sense.
So that means x is equal to plus or minus 3. Don't forget the plus or minus, right? Then what? If x is plus or minus 3, we can go figure out what y is, right?
By trying.
You can use either equation, right? Because we have combined the equations by adding them.
But you can test with negative 3x. His name is Namor.
Namor. Ah, yes. Very good.
That movie literally came out like a week and a half ago. You weren't
What?
saw it and everything?
Huh?
It came out like a week and a half ago.
There was a time we were excited to watch Marvel movies.
Had time to last week, apparently.
I don't know. Like, my friend Paul, like, there was a time, like, by now Paul would have watched it twice.
Yeah.
And he could explain.
Are you Paul?
What's that?
Are you Paul?
I'm not Paul, no. Crazy Paul, my friend, who doesn't have like 5 children to bring to the movie theater, so he can do things like watch a movie twice. You know.
That is so fast.
I don't know. Yeah. Yes and no. Let's see here. Okay, so how do we find y? Plug it in, right? So 5x squared minus 2y squared equals to 43 gives me 5 times 9 minus 2y squared equals to 43 gives me 2y squared equals to 2. 2. Y squared equals to 1. Y equals to plus or minus 1.
Wait, aren't you subtracting 45 from 43 to be negative 2?
But I had to move the 2y squared to the other side. So the answers here, you got yourself 3, 1, 3, minus 1, minus 3, 1, and minus 3, minus 1. There are four solutions to this guy. So, and you're supposed to write them as a list. Like it says, you write like this, comma, this, comma, this, comma, this, comma, this for this problem. This is problem 28, all right? For me, anyway. That's a nice problem. Anyway, I think that's it for today. So, hey, listen, if you thirst for me solving the rest of the problems, just watch like the next section,
Okay.
or possibly the last section. I will get to all the problems at some point today. Sorry I didn't get into your section.